Good day viewers, welcome back to our channel. Today we have the following integration problem. Integral from 1 to infinity, 1 all over z, open bracket 1 plus z raised to power 2, close bracket is z. In this video, we'll be making use of the clever use substitution, okay? So, if you want to decompose into sums of partial fractions, like something look like 1 over z plus something like maybe 1 all over 1 plus z squared. So, we all know that the integral from 1 all over z, well, it may make sense, but the clever use substitution should be the best way to tackle this problem, okay? So I'm going to start. I can select z equals 1 over x. So if you solve for x, x is also equal to 1 over z. So, but from here, differentiating both sides, we get dz is equal to negative dx all over x raised to power 2. Okay, so our integral now, we have integral. So here our lower limit, remember here we have x equal to 1 over z. When z is equal to 1, we get 1 all over 1, so and that is equal to 1. And here we have when z is equal to infinity, 1 over infinity tends to 0, so we have here 0. So here we have 1 all over, remember z here is equal to 1 all over x, open bracket 1 plus, remember that x squared, z squared is going to be 1 all over x raised to power 2, since z is equal to 1 all over x. So here our dz is going to be negative dx all over x raised to power 2. So this is equal to, with this negative sign, if it's cancelled out, so our limit is going to switch from 0 to 1. So here we have 1 all over 1 all over x, so that is equal to x all over. Remember this x square is multiply everything in this bracket, so we have x raised to power 2, 1 plus 1 all over x raised to power 2. Then here we have dx. Okay, so from here now we have this equal to integral from 0 to 1. So we have x all over, opening this bracket, remember x times 1 is x squared plus x squared times 1 over x squared is 1 dx. So I can write this as follows: integral from 0 to 1, x dx up there, then all over 1 plus x raised to power 2. So making my final substitution now, so I can say let x squared equals y. So differentiating both sides, we get 2x dx is equal to dy. So we can make x dx subject of formula, since we have x dx here. So I have x dx is equal to dy all over 2. Okay, wow, that makes sense. So if we have integral from 0 to 1, the limit remains the same. So dy over 2 up there all over 1 plus y. So we have factoring out 1 all over 2 out of the integral. So we have 1 over 2 integral from 0 to y, 1 all over 1 plus y dy. So from here we get this is equal to 1 over 2 the natural logarithm of 1 plus y, then with our limits 0 to 1, so this is equal to 1 over 2. Inserting our limits here, so we have 1 over 2 in bracket natural logarithm of 1 plus 1, that is the upper limit, that is natural logarithm of 2, minus a lower limit 1 plus 0, so natural logarithm of 1. So here we get 1 over 2 natural logarithm of 2 minus natural logarithm of 1 here is equal to 0. So we get 1 over 2 times the natural logarithm of 2. And this is the right answer to the problem. Thank you for viewing. And please make sure you subscribe to our channel, share our videos, and comment. Thank you. Seeing you in our next video.